Hello. Let's try to understand what is a matrix. Matrix is an array of numbers. Generally, this is presented and understood in abstract forms in mathematics classes. But here, I would like to make this math as simple as possible. The objective in the current presentation and in the coming few ones is to simplify matrices and its principles as much as possible. So shall we begin? In the current video and the next few, I would like to express matrices as arrays of observations. Arrays of observations yield results, like say for example making a lemonade, or you could observe different quantities of the ingredients to add to the glass of lemonade. These are called the arrays of observations, and they yield the results. The results could be the total cost of the glass of lemonade or the total weight of the glass of lemonade. Alternately, and most often, the results are known or targeted, and the individual quantities or the unit measures are unknown. Matrix operations help us get those unit measures. Okay, so the observation variables go on the columns from left to right, and each row a different observation is made. Let's see how we can fix this for a lemonade, making a lemonade. The total quantity is shown as the sum of three unit measures. These unit measures are the unit measure of water, say X, unit measure of lemon juice, say Y, unit measure of sugar, say Z. In row 1, or in the first observation, 1 unit measure of water is added to 1.2 unit measures of lemon juice, which is added to 2 quantities or 2 unit measures of sugar, making up a total of 226 grams of lemonade, or simply ml of lemonade. Similarly, row 2 and 3, adding different quantities of unit measures, give different total quantities of the lemonade. These are equivalent to observation variables going on the columns, and number of observations going down the rows for another experiments. Let us try to generalize the example of making a lemonade for all the other experiments. The observations X, Y, and Z multiplied by respective components A, B, and C, or these could also be called coefficients A, B, and C, lead to results, and these results are K1, K2, and K3. We could also expect to determine the individual components X, Y, and Z if they are not given, and the expected results which are known, these are K1, K2, and K3. The previous coefficients times the unit variables, that is A1x, B1y, C1z is equal to K1. These, the matrices that we had previously, they could be represented as product of two matrices. Matrix of coefficients A1, B1, C1, A2, B2, C2, A3, B3, C3, multiplied by the matrix of unit measures X, Y, and Z. And these give the matrix of results on the right hand side, K1, K2, and K3. Let's take a few more examples. Say we have 103 cents in 7 coins, 4 of one denomination or unit measure, and 3 of another unit measure. In order to determine a unique solution for both the unit measures, we need another quantity. Say 78 cents is made up of 3 unit measures of the first denomination coin and 3 unit measures of the second coin. This can be solved algebraically by subtracting the 2 second equation from the first giving denomination of the first coin as 25 cents. Then either of the equations could be used to ascertain the second unit measure as 1 cent. Another example could be a different thing to measure, say profits from various fruits from a fruit vendor. Here we are writing 6 crates of apples A, denoted by A, plus 2 crates of cherries, denoted by C, is equal to $96 in profits. Again, because there are two variables, we need two equations. So the second equation is 3A plus 3C is $78 in profit. Now, what are these two profits? A and C, what are the unit measures? These can be determined by solving the linear equations. The linear equation could be solved by multiplying the second row by 2 by 3 and subtracting from the first. This would yield the equation 2A plus 2C is equal to 52, and after subtraction from the first equation, 4A is equal to 44. Thus, A is $11 per crate of apples. And from either first or second equation, C is $15 per crate of cherries. So in the past two slides, we have shown how you could generalize the matrix multiplications to different such scenarios. Note that the rows and the columns have to be observations and the number of observations, and the number of unknowns should be equal to the number of observations.